Hey everybody, Mr. B here. This is just a short video to try to clear up some issues, learning the difference between whole numbers, integers, and rational numbers and how to classify them. This is what the students glued in their journal today. It's the idea of nesting boxes, that whole numbers are also integers and they're also rational numbers because it's a set within a set within a set. This circle of whole numbers is also inside the circle of integers because they are also integers. And it's also inside this rectangle of rational numbers because the whole numbers are also rational numbers. Integers are integers, and they're also inside the group of rational numbers. So they're rational. Integers are also rational numbers, but integers are not whole numbers. And then rational numbers are just rational numbers. They are not inside the integers category and they are not inside the whole numbers category. So it's a hard way of thinking about this for students, but I'm not going to go into a bunch of detail because this document that they have in their journal gives examples of what whole numbers are. It gives examples of what integers are. It gives examples of what rational numbers are. And it talks about a couple of situations that are kind of rare and things you need to watch out for. Students, we started talking, the very first lesson of the year was about whole numbers and integers. Students have this in their journal. Talks about what the whole numbers are. They're all the numbers you would use to count with and also zero. So they're all the positive numbers and zero. Integers are all those same exact numbers, but also the negative numbers. So that's the only difference between whole numbers and integers, is that integers also includes the negative numbers. But rational numbers are fractions and decimals, basically. That's what they are. But we have to think about these different situations, and I'll give you a couple examples. Okay. So for example, the whole number 2, for example, if I just pick a random whole number, well, it's also a rational number because it can be written as a fraction, 2 over 1. The reason why that works is because that's 2 divided by 1, which is, in long division, is 2 divided by 1. And 1 goes into 2 twice. 2 times 1 is 2, no remainder. So this is equal to the whole number 2. So the fraction 2 over 1, and it can be written as a whole number, but it can be written as a fraction. You can also have that, you can have 2.0 and write it as a decimal. So the whole numbers, like 2 and any other whole number, they're whole numbers, they're rational numbers, they're integers. That's why they're in the middle, because they belong to this category and the other two. So it's often hard for students to imagine it belonging to more than one category, but that's the way these nesting boxes work. Another thing that you might come into is students start to realize that, okay, rational numbers are fractions. So in these examples down here, you got all these fractions. So, okay, rational numbers are fractions. Well, what about fractions like this? Like 15 thirds. That's a fraction. All fractions are division problems, though, and that's the same thing as 15 divided by 3, which is 5. So I know it's an improper fraction, but it's still a fraction, which means it's still a rational number, but it equals a whole number. Well, that means that this is also a whole number. So if I gave them the number 15 thirds, it would actually go here with the whole numbers, because it is a whole number. All whole numbers are integers, and it can be written as a fraction, which makes it a rational number. But that's not true of all improper fractions. You could have an improper fraction like, 5 fourths. Well, that doesn't equal a whole number. 4 goes into 5 one time with 1 left over, so you have 1 and 1/4, or as a decimal, that's 1.25. Okay, that is a rational number because it is a fraction or a decimal only. It doesn't equal a whole number, and if it doesn't equal a whole number, then it cannot be an integer. So I don't want students thinking that all improper fractions will be whole numbers, because many of them aren't. Okay, and then just maybe the idea that there's regular fractions out there that could turn into a whole number. Well, that's impossible. All regular fractions or regular mixed numbers, if I'm just thinking like 2/3 or, 2 and 2/5 or something like that, none of those are going to turn into a whole number. Even if you divide them out, you'll see. You're gonna get a decimal when you divide this out. You're gonna get a decimal when you convert that to a decimal. So we've been working on converting fractions to decimals. Well, why have we been doing that? The reason why we've been doing that is so if we convert this to a decimal, we'll know it's a decimal. It's a rational number, not a whole number. And if we convert this, we know that it is a whole number. So there's purpose behind what we're doing each day as it carries over to the next day. So not a lot behind that, but parents and students alike who are watching this video, trying to get some help on the assignment that I sent home. This paints a really good picture of these categories, but you just got to remember that it's a category. It's a category inside of a category inside of a category. One way to think about it is, some might use a Venn diagram like this. Okay, you can have something here and you can have something here, and then this area is where they're the same. So it's similar to that. In our case, you'd have to have a circle for integers, a circle for whole numbers, and a circle for rational numbers. But that's not a good diagram for this, because now you're talking about 1, 2, 3, 4, 5, 6, 7 categories. Well, we don't have 7 categories. We have 3 categories: whole numbers, integers, and rationals. If you use this model for that, you're going to have a bunch of spaces where nothing fits because you have more categories than you have things. So the nesting box model is actually a better way of showing that. I encourage you to focus on the model, to read through these descriptions and think about the examples that are in there. If students are frustrated with classifying them and where they go, they've got to come back to here and look and see where it's going to end up. Hopefully that clears things up a little bit. I hate to just go on rambling about this. It's a weird concept to think about, but it's pretty straightforward if you get in there and review the material. So hope this helps, even if it only helps a little bit. I'm glad to provide this. And students, if you need more help or you're having trouble with it, as always, let me know. Thanks.